Lads, this is called proof by induction, okay? And it's based off series. Now, as we learned earlier when we did signals of series, right? T1 is 1, T2 is 4, T3 is 7, T4 is 10, and Tn is 3n minus 2. Is everybody okay with that? So the formula Tn equals 3n minus 2. That will give you any equation you want. It will give you any one you want. If you want to find out what T4 is, what can you do? Just lob in 4 and what happens? 3 times 4 take away 2? 10, isn't it? You happy enough with that? Okay, next thing. The formula on the right refers to Sn. Now does everybody remember what Sn is again? S1 equals T1. S2 equals T1 plus T2. S3, anybody? Now, this is where I start to get a bit fancy, and you need to understand this trick, okay? Sorry, that's T2, it's T3. Now, S4, anybody? It's really obvious, isn't it? And I could go on like that forever, can't I? Right? Now, the trick what I want to show you is this. I want to make this abundantly obvious, right? I could also write S4 as what? I could write S4 as S3 plus T4. Would everybody agree with that? Is there anything I've said that's troubled you so far? Alright. Next thing. By that logic, what could I say S100 is? S99 plus. Would that make sense? Nextly, what could I say Sn plus 1 is? Sn plus 1. 100 turns into 99, which means you take 1 away from it. So what's n plus 1 take away 1? Sn. And then plus t what? The same number as what you have over here. Would everybody understand where that comes from now? S of n plus 1 equals S of n plus Tn plus 1. It's the same thing as S100 equals S99 plus T100. It's the same thing. Okay, we all good? Now, that is the underlying premise for these questions. Alright? All that was word for word in the video as well, but we'll keep going. Alright, now, next thing we're going to do is this. What we're going to do is we're going to prove true. We're going to prove that this formula works for n equals 1. So step 1 is prove true for n equals 1. So what does that mean? It means we're going to take T1, which equals 1. Is that alright? And what does that mean for the right hand side? We're going to pretty much take S1, which is 1 over 2, 3 times 1, take away 1, a half of 2 equals 1. Then you can say LHS equals, what's that mean? Left hand side equals right hand side, and then what you say? True for n equals 1. Is that okay with you guys? That's always the first step. Prove that it works for n equals 1. Right? I'm going to rub out the red step. I'll just move it somewhere, and now I'm going to start off with the next step after this. Right? So that's step 1. Okay? And step 1 is quite easy. Now, we're going to work on step 2 now. So I'll just move step 1 up here, out of the way. Right? Now we're going to, as I said, work on step 2 now. Alright? Step 2, which we'll do in green, is assume true for n equals k. Okay. Anywhere you see an n, replace it with a k. You're essentially saying that that's no longer Tn, that's now Tk, that's no longer Sn, that's Sk. Is that alright with you guys? So you say 1 plus 4 plus 7 plus 10 plus dot 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 plus Tk, which would be 3k minus 2, and you're saying that it equals k over 2 into 3k minus 1. Is that alright? Now in part 3, prove true for n equals k plus 1. Alright? So here's what's basically happening, okay? You originally went all the way up to tk, didn't you? tk was your last term, wasn't it? You went t1, t2, t3, t4, tk. Now you're going higher again, aren't you? So what do I have to include this time? I have to include tk plus 1. And this is no longer sk. What is it now? Plus 1. Alright? And so what we're going to do is going to write down what we did last time. Except it's going to be in blue this time. Alright? And we're going to do it here. Alright? So we're going to do exactly the same thing as last time. We're going to go 1 plus 4 plus 7 plus 10 plus ... plus 3k minus 2. Now how do we figure out what the next one is? Replace n with k plus 1. 3 times k plus 1 take away 2. What is 3 times k plus 1 take away 2? 3k plus 3 take away 2, which is 3k plus 1. Is that right? It was a linear sequence, wasn't it? It's going up in threes every time, yeah? 1, 4, 7, 10. That means the next gap should also be a gap of 3 between the two of them. So that could be the shortcut way of doing it. Okay? Now, and what are we saying on the other side? Well, this must equal s of k plus 1. But what is s of k plus 1? What is it? Replace k with k plus 1. K plus 1 over 2. Now, I have to do 3 times k plus 1. Take away 1. So I'm just going to change this here. So it's 3 times k plus 1, take away 1. Because you're replacing n, this n here, you're replacing it with k plus 1. And what you're going to get, 3k plus 2, is it?
Yeah.
Now, your job is to conclusively prove that it balances. That the left hand side, underlined in black, equals the right hand side, underlined in red. You have to prove that. Now, using the same trick that we did earlier, where we said that, using the same trick earlier, that when we said that, what was it? We said that S100 equals S99 plus T100, wasn't it? What I'm trying to say is that S of k plus 1 is the same thing as S of k plus tk plus 1. Is that alright? So, if I highlight this section here, this part here, what can I replace that with? I can replace it with that part there, can't I? Because in the previous line I assumed that the two of them are equal to each other, so I'm allowed to replace that in. Okay, and that's essentially what I'm doing. So now I'm going to say, no bother, k over 2 into 3k minus 1. That's that blue part there, yeah? And what else is there? The 3k plus 1 is there. And that has to balance out the red side, which is k plus 1, 3k plus 2, all over 2. Alright, step 1, what's the common denominator of all this? 2. So what I'm going to do is I'm going to try and turn the left hand side into the right hand side really quickly. So I'm going to put all this over, I'm going to put this over 2 like so. How do I fix that then? How do I put that over 2? 6k plus 2 over 2. You on board so far? Okay. There is a no, there's not a fast way of doing this, right? So multiply the top out. I'm going to multiply the top out. 3k squared, yeah? Minus k plus 6k plus 2. So would everybody agree with 3k squared minus 5k plus 2 all over 2? And what happens when you factorise that? So what happens when you do a standard factorisation? Sorry, plus 5k. Very important. So what happens when I factorise the left side? When you factorise a standard quadratic equation that you've been doing since second year? Yeah, you get the same thing on both sides, don't you? And what does that mean? Right? Now this is where the idea of mathematical induction comes true, alright? So I'll just grab where did I paste that thing onto earlier? Nope. Just give me a sec. There you are. Alright. So this little two-liner at the end, alright, is all you need. Alright, and I'll explain what it means. P of k plus 1 is true if P of k is true. The two of these balance, don't they? And what's the reason they balance? The reason they balance is we took out this blue part and replaced it with this blue part up here, correct? And we assumed is the key word. We assumed that balanced. So P of k plus 1 is true if P of k is true. But here's the catch. At the very beginning, did we not prove that P1 works? Yeah? So k equals 1 is definitely true. Would you agree with that? And that means that what will also be true? If k equals 1 is true, that means k2 is true. And if k equals 2 is true, what does that mean? K equals 3 will be true. And so on and so forth for all the values, all the natural numbers. So that's all you have to say at the end. P of k plus 1 is true if P of k is true. Hence, by the principle of mathematical induction, that is basically what I showed you there a second ago. 1 proves 2, 2 proves 3, 3 proves 4, all the way up. P of n is true. Is that alright? Now, it is quite difficult. Alright guys, you essentially start you off with introduction. That's T1, that's T2, that's T3, that's T4, that's Tn. This formula over here, anybody? Sn. Alright? And what did we say step 1 was? Prove true for what? For n equals 1. Well, if n equals 1, you're talking about the left hand side will equal T1, and T1 is 1 over 6. The right hand side will be S1, and S1 equals 1 over 2 times 1 plus 2, which is also 1 over 6. Then you say 3 dots means therefore true for n equals 1. Right? That's the first part done and dusted. Right? And it's always really easy to get 10 marks in this. Now, next thing we're doing after that is we're going to go assume true. Assume true for n equals k. So now it's 1 over 2 times 3 plus 1 over 3 times 4 plus 1 over 4 times 5 plus 1 over 5 times 6 plus dot dot dot. Now that was Tn, now it's Tk, and we know that Tk is 1 over k plus 1 by k plus 2. That's no longer Sn, it's Sk now. Okay. Now, step 3. prove for n equals k plus 1? So that means you don't stop at tk, you actually have to add on tk plus 1 as well. I'm going to pause here and let you finish it off yourself. So, to get temp marks here, you rewrite the whole thing again. 1 over 2 over 3 plus 1 over 3, 4. Yeah, it's right. Now, the difference is you don't stop at tk. You end up stopping at tk plus 1. So, can everybody tell me what one this one is? Would everybody happy that's tk? The k term. Now, to get k plus 1, what you need to do? Anywhere you see k, replace it with k plus 1. So what happens when you replace k with k plus 1? What do you get? You get k plus 2, and then when you replace it here, you get k plus 3. Alright? So that's tk plus 1, and this is s of k plus 1 over this side, which is k plus 1 instead of k. And what's k plus 2 when you're replacing k equals k plus 1? K plus 3. Alright, is everybody cool with that last move we did? Alright? Now, what's my next move? I'll highlight all of this, all the way up to there. What does this yellow part represent? S what? It represents SK. Once again, S100 is the same thing as S99 plus T100. Therefore, S of k plus 1 is the same thing as S of k plus TK plus 1. And TK plus 1, as we did earlier, is that one there. The blue part is TK plus 1. The yellow part is SK. Everybody on board with that? And what is the pink part over here? No, that's yellow. What's the pink part over here? SK plus 1. That's essentially what I'm doing, that little switcheroo on the bottom, alright? So we get rid of all of that. Right. Now, so we're subbing it in for this part here. This is SK here. So you're getting subbed in. So now it's k over 2 into k plus 2. And then I have to add on this here, don't I? 1 over k plus 2 by k plus 3. And then equals s of k plus 1, which is k plus 1 into 2 k plus 3. Alright. Has anybody have any idea how to turn the left part underlined in red into the right part underlined in black? What would be a good way of starting this off? Common denominator might be a good start off. So what do I need to put on both sides? I'll put k plus 3 top and bottom here, yeah? We're not far away from this. Multiply it out and what do we get? Did I make a mistake?
2 on the right one. 2 on top.
Ah, excellent, Mick. So Mick said we need a 2 here, and Mick's not wrong. Okay? So I'm going to get k squared. I'm going to get 3k. And I'm going to get 2. And that's all going to be over 2 into k plus 2 into k plus 3. That equals k plus 1 into 2 times k plus 3. Now, I'm looking and comparing, and do you know what I think is going to go missing? When we factorise the red part, what do you think happens? K plus 1 and k plus 2. Shh. Okay. And what cancels? Huh? Yeah. And do they equal each other? They do. And then you go back here, so where did I put it? Oh, there it is. You go back here, you get your spiel, as I call it. Extra pronunciation on the SP, spiel. And so P of k plus 1 is true if P of k is true, hence by the principle of manual induction, P of n is true. We all good? Okay.